Consider the differential equation dy dx equals 3 minus y cosine x. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers.
Part A. A portion of the slope field of the differential equation is given below. Sketch the solution of the curve through the point 0, 1.
For this part, you must look at the lines in your graph and follow these lines. You should start at point 0, 1, and from there, you will do the average between them. In the right side, your function will going downward, and from the left, it's going upward. Write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2.
So to find the line tangent to the curve, we need to use the point slope formula, which equals y equals m times x minus x1 plus y1. So we have the point 0, 1. We need the slope to find the line tangent. Let's go ahead and plug in 0, 1 to the derivative to find our slope. We plug in 0 for x and 1 for y, we get 3 minus 1 cosine 0. Cosine 0 is 1 and 3 minus 1 is 2, so 2 times 1 is 2. So this is our slope. Now that we have our slope and our point, we plug it in our point slope formula. It will give us y equals 2 times x minus 0 plus 1, which could be simplified to y equals 2x plus 1. Now that we have our equation for the line tangent, we need to approximate f of 0.2. What we do is plug in 0.2 in our x and simplify, which equals y equals 2 times 0.2 plus 1, which equals 1.4. And y of 0.2 equals 1.4. Find y equals f of x, the particular solution to the differential equation with the initial condition f of 0 equals 1.
First, we need to separate our x's and y's. So we put on one side the x's and the other side the y's. Leaving it, dy divided by 3 minus y equals cosine x dx. Now we can integrate. The integral for dy divided by 3 minus y equals negative ln absolute value of 3 minus y, and the integral for cosine x dx is sine x plus c. Now, to solve for y, we know that the absolute value of 3 minus y equals e to negative sine x plus c1. Now we know that all this equals c2 times e to the negative sine x. To remove the absolute value, we need to evaluate positive or negative in both sides. So this equals 3 minus y equals c3 e to the negative sine x, which means that y equals 3 minus c3 e to the negative sine x. Now let's plug in 0, 1 into our function to find c. Now that we have solved for c, we know that c equals 2.